places where there were antiretrovirals introduced. And so some colleagues at UC San Diego and at the World Bank collected data on exactly those people who were like brought back from the dead, and they collected data on them over the course of a few years, and their labor productivity goes from 0, because they're literally on their deathbed, to basically back to where they were before, or back to normal, healthy, uninfected, I don't use the word normal, but uninfected, healthy people. So it's almost miraculous how in the span of weeks or a couple months, labor productivity is just back to where it was before. Now these folks will always be infected, and they'll have to keep taking antiretrovirals forever, or else they'll die. Basically the disease will return. And it's not a simple regimen. You have to take multiple pills, you have to take them every day. But over time, over the last decade, they've worked out systems to have quite high compliance with that treatment regime. So that's been another big success story. Yeah. 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 They've simplified the cocktails a lot. They've reduced the number of pills people need to take. So basically, over time, through various clinical trials, they've made it less and less complicated and easier to sort of remember with rules of thumb, et cetera, combining different drugs into one pill, et cetera. So the whole process has become much more streamlined than it was 10 years ago. Of course, that's going to help with compliance and adherence. So they've put a ton of effort into that. And that's been part of this U.S. government-funded foreign aid program, was funding basically not just theoretically how to create the drugs, but how to really implement it in the field. And that's been a big success. So when we were looking at this clinic and spent a few days there in 2003, they were just figuring all this stuff out. Like, gosh, how are we going to get the clinics to get people to adhere? And that was an open question, actually. And one of the questions that was being raised by pharmaceutical companies or some critics at the time was, you're going to roll out ARVs in Africa. People don't have the public health infrastructure implemented. You're going to have this partial compliance, and people are going to be left off worse than they were before, because you're not going to have a success story. You're not going to save lives, and you're going to breed all these drug-resistant strains or something. So that was one of the counter arguments that was floating around, which isn't totally crazy, but the reality has proved a lot more successful than had been feared. Okay, so let's talk about impacts. One impact we're going to focus on, and this is in the Fox et al. Article, has to do with labor productivity and labor turnover. So it's just a bit like the question before. If you're sick with AIDS, how much less productive are you? Of course, eventually if you die, your productivity goes to 0, but people get sick over time, and they live with AIDS over time, and the question is, over that time path, what happens to your labor productivity? So that's one channel. That's what we're going to have the sort of best data on. What are some other just direct, first-order important channels you would think of when you're thinking of the effect of HIV/AIDS on economic development in Africa? Beyond like contemporaneous adult labor productivity. Yeah. Okay, so you're pointing basically to sort of public finance implication, which is like, this is very expensive, there's sick people, that the health system is strained, and a lot of resources are now kind of going in here that would have gone into other sorts of public investments, infrastructure, other health investments, educational investments, et cetera. So there's a public finance implication that may affect, let's say, public investment, is what you were saying. No. There we go. Okay, what other channels? So if I'm sick as an adult and I get sick, I die, my children, you're saying, may not get the education they need, they may not be productive. So there's this sort of intergenerational issue. Even if the kids aren't infected, they're affected by my infection. And this is the case, very well publicized case of AIDS orphans. If people whose parents die get less schooling, have fewer opportunities, I have some data on this. I have a paper on this, again, in Western Kenya, where we look at what happens when kids' parents die. And when kids' parents die, they drop out of school. They're much more likely to drop out of school. It's not surprising, but these are real effects. Yeah. That's a great point. So in addition to public finance being focused on this issue, foreign aid will go here rather than in other needed investments. Okay. Yeah. Yeah, so you mentioned foreign investment. We've already talked about sort of public investments, and this is sort of human capital investment. There's just like maybe direct investment effects. And you're focusing on the foreign angle. So you're saying foreign direct investment, FDI, could fall. Domestic investment could fall too. And one of the reasons domestic investment could fall is, imagine I'm thinking of starting a business, but I'm infected. And this is the era before antiretrovirals. I don't know how long I'm going to live. Maybe 5 years, maybe 2 years, maybe 10 years. I'm going to invest less. My time horizons are just much shorter. Is that the point that you were going to raise? So, there's this big, almost any model you would have would say, as my time horizons get shorter, my investment's going to fall because I have less time to reap the return on that investment. And that's just like a fundamental channel that you can see all of these things as being sort of manifestations of that. Yeah. So another channel could just be tourism. That, again, if there's a perception that it's dangerous or risky to be in sub-Saharan Africa, it could affect tourism. So that's another channel. Any other channels or thoughts? Yeah. Mm-hmm. You consume more rather than investing, say. So if you're basically what you're earning today, you're consuming rather than investing in the future. You'll spend a lot today, but in the future you'll be poor because you won't have made the necessary investments to sort of grow in the future. So you'd expect growth to fall. Yeah. But you would consume more today, but in the long run it would affect growth, or even in the medium run. Okay, so you guys have named, I had sort of listed these out: human capital accumulation with orphans, investment, savings. You already mentioned a couple of other channels. So there really are a lot of reasons why we'd be concerned with this. So let's try to understand it. We're going to focus on labor productivity, but we face a methodological issue. I've just spent a week and a half or 2 weeks convincing you that randomized trials are great. God, there's so many omitted variables. We listed like 100 of them. We really want to do randomized controlled trials. What do we do if we don't have a randomized controlled trial? So in some cases with HIV/AIDS, you might have it. For instance, if the spread of antiretrovirals in different locations for some reason was randomized or rolled out in an experimental way. But if you don't have that kind of variation, and you're just looking at what happens as people get sick or as the disease spreads, how can you understand the impact of this disease? That's very important. There'll be a lot of settings where you can't run, where it's either impossible, too expensive, unethical, logistically challenging to run a large experiment for something you want to do, or maybe it's possible to do, but there's no cooperation from local authorities because it's politically difficult. So in that case, what do we do? So what we're going to do in the next 2 months of the course is talk about non-randomized approaches to dealing with these issues of understanding program impact. And this is really important because in a lot of real-world studies, this is what we're going to have to use, non-experimental approaches. So the first one we're going to talk about is going to be difference in differences. What difference in differences does is it utilizes a different type of data than the data we've been talking about so far to make progress. So difference in differences analysis relies on what economists call panel data, and what most other researchers, say in public health, call longitudinal data. So demographers in public health call it longitudinal data. We call it panel data. And what this is data on the same unit. It could be a person, it could be a village, the same unit over time. So we have data on multiple units over multiple time periods. That's why it's called panel, right? And this is our question today. Under what assumptions can we talk about causal effects, meaning the impact of a program, the impact of an event on some outcome that we care about when we don't have an experiment? All of these non-experimental approaches I'm going to talk about rely on certain assumptions. Some of those assumptions hold in certain cases, others hold in other cases. And through all the cases we're going to see this term, you guys are going to gain a lot of intuition, I hope, about when to use one method or another. In some cases, a certain approach makes perfect sense, but it would be crazy to use in another setting. So we're going to talk in a lot of detail why you would use certain methods and not others, starting with difference and difference. So let's go back to the kind of equations we had last time and the previous time. This is like literally the exact same slide we had before. There's some outcome y, there's some treatment t, some omitted variable or unobservable x, and if we compare the treated and the untreated, we get the true effect of the bias term. Okay, you guys know that. Now here, let's interpret T broadly. It could be a treatment like a deworming pill or ARV, or it could be something else. It could be any sort of event. It could be falling ill with AIDS. We want to understand the effect of AIDS on labor productivity. The indicator variable T could be falling ill with AIDS, and Y could be your labor productivity, earnings. So that's actually the regression we're going to look at. Okay. We're going to modify equation 1 now. This is a slightly different version of equation 1. I should have called it 1 prime. The difference here is the subscripting. So before we had Y sub I. We had one observation for each individual I. Now, we have Y sub IT, little t. T is time, and we're going to allow there to be 2 time periods. Again, just for simplicity. We could generalize this as many time periods as you want, but all the kind of basic intuition goes through with 2 time periods. So that's what we're going to do. There's period 0, t equals 0. That's pre-program, pre-event, baseline, what we call baseline. And then t equals 1 is post-program, or follow-up. People call it end line, but before and after data, 0, 1. And again, the event here is before and after falling ill with AIDS. And the outcome is their productivity. And particularly in the Fox et al. Study, when you take a look at it, the outcome they look at is they have data, very detailed data from a tea plantation. And the managers of the tea plantation kept track of every single worker's daily productivity. How many kilos of tea leaves did they pick? So this is a good measure for us because it's just like a real physical measure of your labor productivity. How much energy and strength and endurance do you have to go out and do this work? Where literally the value of your work is measured tea leaf by tea leaf because they're selling those tea leaves at a certain price. So this is a good measure of labor productivity. Okay, so there's equation 1. Period 1, the post-program period, is basically going to be like our old equation 1. In our old equation, we said, look, after some treatment has happened, we get to compare the treated and the untreated. And we have this bias term that we're concerned about. So the post-period, I'm not even going to go through the algebra, it's exactly like our old equation 1 in the post-period. That is y sub I1, post-period. What's more interesting is the pre-period. So this is equation 2. The pre-period is equation 3. Before the event, before anybody becomes ill with AIDS, imagine we can measure their labor productivity. Think about why that's really useful. Now we've got data on the same person before and after they got ill. So effectively, we kind of have these like 2 measures of the effect of the treatment. One measure is just the difference between t equals 1 and t equals 0, the difference between the treated and the untreated. The second measure is the difference over time. What happened to me over time? And we're going to combine those 2 differences. That's what's called difference and differences. We're going to combine those 2 differences in a particular way to get at the treatment effect. Okay, so this is the pre-program data. The difference between the productivity of t sub I1 equals 1 and t sub I1 equals 0. So who are those 2 groups? This group are the people who are going to become ill later. These are the people who are still going to be healthy later. But we know who they are. We have data on period 1. So we can go back and match data on this individual I over time, and we know what their productivity was before they became ill. Okay, so why is this useful? Let's go through the algebra. The algebra is exactly the same as before. But now you're going to see there's no treatment effect here. Why is that? There's no treatment effect because everybody at period 0 is healthy. We're going to only focus on a sample of people that did not have AIDS in the baseline period. They were all healthy in the baseline period. That's what the 0 here means. So all we have in period 0 in the baseline is a bias term. Let me pause for a second because I think I'm going a little fast. Any questions on this? Yeah. It would be like that. It would be like that. Now we don't rely on that in the deworming case because we had an experiment, so we use that randomized variation. Yeah. Right, so what you just said is an interpretation of this term. This difference tells us about the average differences between those who end up getting sick and those who don't end up getting sick. So maybe at baseline, those who ended up getting sick just had lower productivity. We can account for that here. This is telling us about any baseline differences between these groups. So that's what's so powerful about this approach. We're characterizing, in some ways, we're characterizing the omitted variable bias here. How else might you think of that term, or any other thoughts on this, or questions on this algebra? Okay, so let's put these together. The difference in differences takes the difference between equation 2 and equation 3. Each of those is a difference between the treated and the untreated. The difference in differences is the change over time in those differences. That's why it's a difference in difference. So we're taking equation 2 minus equation 3. That's what those 2 terms are. That's the algebra. And we end up with this expression. We end up with B, the true effect, plus the omitted variable bias term in t equals 1, that's up here, minus the omitted variable bias term in t equals 0. And the big question here is, when is that second term likely to be 0? If that term is 0, we're golden. If that term is 0, we're left with B. We have the true effect. So when is that likely to hold? Yeah. Right, if everything else were the same, except the event changed, we'd fully account for the omitted variable bias here, and we'd just difference it out. If not everything is stable over time, we may not difference it out. What may change over time? What are some reasons why these 2 groups might have different omitted variable bias terms over time? What would be the kind of logic to that? Let me give you one example. Imagine that for whatever reason, the people who ended up getting sick were better workers. They were just star workers on this farm. They had higher earnings. The omitted variable bias actually suggested that they were more productive at baseline. And maybe on this farm, if you're more productive, you get promoted, you get higher earnings over time. What if the sort of like wage gap between these 2 groups would have gotten bigger and bigger over time for some reason? So if you're just a high ability worker, you keep getting raises, and if you're a mediocre worker, your wages are flat. Then actually, you might have seen some divergence in their earnings over time, right? That would be a case where things aren't the same over time. Even if the people are the same, the setting changes over time. People of a certain ability maybe are treated differently over time. That's the kind of concern we're most worried about. So any other thoughts? What would be another example or case? Yeah. Well, that's pretty interesting. So you're saying like getting sick isn't just like my innate labor productivity. The stigma could affect what I do on the job or affect my productivity. And then what we're getting in B here isn't just my actual physical strength and ability. It's the result of all this discrimination. So that's an interesting interpretation that will kind of change our view of what we're measuring with B. Yeah. Yep, that's an interesting finding. Keep that thought in mind when I show you some of the time plots next lecture. There's basically evidence, suggested evidence for what you said. Last comment? Yeah. Exactly. So you've interpreted this exactly right. It doesn't have to be a fixed sort of omitted variable effect as long as it's parallel. As long as the gap is constant, parallel trends are okay. And that's actually the term we use in the applied econometrics. You're looking for groups with parallel trends before the treatment. It can be trending. Things can be changing, but they have to be changing in parallel. If they're changing in parallel, then the gap between them will stay constant and it'll difference out. Okay. So that's enough for today. I think Pierre and Jonas have solutions, and I will see you guys on Tuesday.